Okay. Today, today we shall be talking about development of Arch and Garch model. So that is our target today. Development of Arch and Garch model. And today we shall be using Garch 1 model using EVIEWS. Okay. So today we shall develop a Garch model as below. And here Garch 1 means this 1 and 1 means there is a one arch term and there is another one Garch term. So one arch and one Garch. So that is called Garch 1 model, and we shall develop it today. Okay, so this Garch 1 model has two parts. One part is mean equation, that is part number 1, and the second part is variance equation. So we have two parts. One is mean equation, you can see from here, that is 1.1, and second part of the Garch 1 model is variance equation, which is this one, equation number 1.2. So these two equations we shall solve today. Okay, so first we talk about equation number 1.1. Here you can see BBR is the dependent variable, C1 is the constant, C2 is the coefficient, BSR is a independent variable, and E is the residual. That is equation number 1.1. And here BBR means Bangladesh bond return, that is BBR, and C means constant, and what is BSR? Bangladesh stock return, and E is the residual. And here done, we have taken daily data of 35 days, not 35 days, 350 days daily data we have taken of all the variables. And what we have done, we have run these models. We have run model 1.1. After running, we have got the residual. After estimating mean model 1.1, equation 1.1, we have got the residual. And what we have done, we have plotted the residual from equation 1.1 here. So this one actually is the residual from model 1.1. You can see this is residual, right? And it is called figure 1.1, residual of Bangladesh bond return of 350 days. Okay, so this is residual, you can see from here. This is residual that you can see from here. So what is happening now, you just go down below. So my plan is to interpret the result, interpret the meaning of the residual that I shall be now. We see from figure 1.1, figure 1.1 means this one, right? We see from figure 1.1 that there is a prolonged period of low volatility from 1 to 85, and so there is prolonged period high volatility from day 90 to day 180. What does it mean? It means that you can see from here, from day 1 to day 85. Okay, this is all day. The horizontal axis are all day. Day from 1 to 350 days, right? From 1 to 350 days. And you can see day 1 to day 85 until 85 the volatility is low. Low volatility for long time. 85 days continuously. 85 days continuously there was low fluctuation for a long time. 85 days were low volatility. Again, you can see from here, from the figure 1.1, there is a high fluctuation from day 90 to day 180. You can see from here the huge fluctuation. You can see from here, right? This is the fluctuation from day 90 to day 180. That means high fluctuation for a long time, right? High fluctuation, high volatility for a long time. So, in other words, periods of high volatility are followed by periods of high volatility, and periods of low volatility tend to be followed by periods of low volatility. I'm saying again, in other words, periods of high volatility are followed by periods of high volatility, and periods of low volatility tend to be followed by periods of low volatility. What does it mean? It means that from day 1 to day 85, small volatility actually cause another small volatility. One small volatility causing another small volatility. And here you can see from day 90 to day 80 what has been happened. One big volatility has caused another big volatility. That means one big shock, one big fluctuation has caused another big fluctuation, and that has happened for a long period. So when this thing happens, then we can introduce a Arch and Garch model. when the residual behave like this. When the residual behave like this, then we can introduce a Garch and Garch model. So that I am saying here, this suggests that residual or error term is conditionally heteroscedastic, and it can be represented by Garch and Garch model. That means when the residual behave like this, then we can introduce a Garch and Garch model. Okay, now we can introduce Garch and Garch model, because our figure 1.1 is suggesting us to introduce a Garch and Garch model. And here we shall introduce what? We shall introduce a Garch 1 and 1 model. Okay, we come to the another equation of the Garch 1 model is here, and we call it variance equation, and this one is the actually Garch 1 model, right? This is the Garch 1 model. You can see from here, residual derived from mean equation is used in making variance equation 1.1. That means 1.2 equation actually has derived from using the residual of equation 1.1. Okay. Now here you can see these are all independent and HT is dependent variable. What is HT? HT means, what does it mean? The variance of the residual derived from equation 1.1, that is HT. It is also known as current day's variance or volatility of Bangladesh bond return. So what is HT? The volatility of Bangladesh bond return, that is BBR, right? So that is HT. And what is BBR? Bangladesh bond return. And C3 is the constant. You can see from here, C3. And then what is C4? C4 is the coefficient of HT minus 1. HT minus 1 means 1 period lag of HT. That is called HT minus 1. Okay, here what is HT1? Previous day's residual variance or volatility of Bangladesh bond return, that is BR, and it is also known as Garch term. That means this one actually called Garch term, this one, right? So what is happening here? HT is the current period volatility, right? HT is the current period volatility, and HT minus 1 is the previous day volatility. Suppose this one HT is the today's volatility, suppose, and HT1 is yesterday's volatility. That means today's fluctuation depends on yesterday's fluctuation. Today's fluctuation is influenced by yesterday's fluctuation, which is HT minus 1. Okay, then I talk about E square T minus 1. What is it? And the coefficient is C5. What is E square T minus 1? It is here, you can see E square T minus 1. It means that previous period's squared residual derived from equation 1.1. It is also known as previous day's bond return information about volatility, and it is arch term. So in this model, here is a one Garch term and one arch term. So that is why we are calling it Garch 1 because here is one arch term and one Garch term. And we can see some more variables such as IBR and another one PBR, and C6 is the coefficient of IBR and C7 is the coefficient of PBR. Okay, what is IBR? IBR is Indian bond return. It is an exogenous or predetermined variable. And what is PBR? Pakistan bond return. It is an exogenous and or predetermined variable. So what we shall do now? We shall actually estimate this Garch model 1.2, provided we have all the data, and we have already collected data to estimate equation 1.2. And here you know that IBR and PBR are also known as variance regressor, as they can also contribute in the volatility of Bangladesh bond return in equation 1.2, right? So actually IBR and PBR also contribute in the volatility of HT. What is called HT? Volatility of Bangladesh bond return. Okay. Equation 1.2 is a Garch 1 model, as it has one arch and one Garch term. In other words, it refers to first order arch term and first order Garch term. In other words, it refers to first order arch term and first order Garch term. Higher order Garch 2 and 3 can be appointed also, but many researcher prefers to use Garch 1 for modeling the volatility of bond return. So that means you can use the higher order Garch model, but we have here introduced Garch 1 and 1 model, because Garch 1 and 1 model provides better result, and many person also suggest to use Garch 1 model. And here we shall estimate the mean equation 1.1 and variance equation 1.2 simultaneously under EVIEW environment. Okay. Then I talk about what is the objective of the study. This study aims to model the volatility of Bangladesh bond return and factors affecting the volatility in the returns of BBR. That means what are the factors are affecting the volatility of Bangladesh bond return. It means that what I want to say here, as I said, HT is the volatility of Bangladesh bond return. So what are the factors are affecting HT? Is it Garch term? Is it arch term? Is it IBR? Or is it PBR? Or is it all that influence or contribute in the volatility of HT? Okay, so that is our objective of study. Okay.